Hello, everyone, and welcome back to Beyond Compression, the podcast where we share ideas, stories, and best practices around centrifugal air and gas compressor technology. Each episode will bring you insights from the people helping to shape the future of our industry. I'm your host, Barbara, and today we're talking about something that almost every plant deals with, but very few fully account for. We're talking about the long-term cost of compressed air. Because while most conversations start with the price of the compressor itself, that's actually just the beginning. If you've ever selected a compressor because the upfront number looked reasonable, only to wonder why later the energy bills, maintenance costs, and downtime keeps creeping up at your plant, then this episode is for you. And with me today is Zach, one of our associate product managers here at FS-Elliott. Zach, thanks for joining us.
Thanks, Barb. Glad to be here. And yeah, this is one of those topics where the real story doesn't show up on a purchase order.
So let's start there. When people think about the cost of compressed air, what do they usually focus on first?
So most people focus on the equipment price. They're comparing models, horsepower, flow, pressure ratings, and trying to get the best number they can up front. And that makes sense. Capital cost is easy to see. It's tangible. The problem is, it's usually only a small fraction of what that system will actually cost over its lifetime.
And you're right. Compressed air is one of those utilities people don't think about much when it's working, until the cost or the reliability becomes really hard to ignore. And I've heard people describe compressed air as everybody's utility, but unfortunately nobody's budget.
Yeah, I've been in facilities where we asked, who actually owns the compressed air system? And the answer was simply a very long pause. Operations thought it was maintenance. Maintenance thought it was engineering. But engineering thought it was facilities. And because no one truly owned it, no one was tracking the full cost. Then energy prices went up, and suddenly everyone was surprised, even though the system itself hadn't changed at all.
And that's the thing. When no one owns it, no one's really watching the full cost. That's when those hidden costs start creeping in.
Exactly. And when you do the math, it adds up fast. In a lot of facilities, energy alone accounts for 70 to 80% of the total cost of compressed air over time. And that's before you factor in things like maintenance, consumables, and the cost of downtime.
And that number surprises people every time, doesn't it?
Every single time, actually. Because energy cost isn't a one-time expense. It shows up every hour the system is running, and even small inefficiencies compound fast.
Okay, so let's talk about that for a second. What are some of those small things that end up driving big costs?
One of the biggest is pressure. There's a simple rule of thumb in compressed air. For every 1 psi increase in system pressure, energy consumption increases by about 0.5%. So think about it. If you're running 10, 15, 20 psi higher than you actually need, that adds up very quickly.
That happens a lot, doesn't it? Systems running overpressurized without anyone really noticing?
Yeah, quite a bit. A lot of operators will bump the pressure up just to give themselves a little buffer, avoid alarms, avoid interruptions. But the trade-off is higher energy use, more leakage, and more stress on the equipment. So what feels like a safety margin is often just another hidden cost.
And if pressure is one piece of it, what are some of the other things that tend to get overlooked?
So your control strategy plays a huge role as well. Partial load operation is another big one. For centrifugal compressors, they are most efficient near full load. So when they spend most of their life either unloaded or lightly loaded, the energy cost per unit of air goes up. Then you've got motor efficiency, pressure drop across filters, air quality issues, and overall system health. None of those things jump out day to day, but together they quietly drain money.
Usually, this is where system audits come into the conversation. Can you explain why audits are valuable?
Well, it really comes down to that old idea, you can't manage what you can't see. An audit gives you a data-driven snapshot of how the system is actually operating, not how we think it's operating. It looks at energy use, pressure levels, leaks, air quality, equipment health, and most importantly, it establishes a baseline. Once you have that baseline, you can start prioritizing improvements that actually move the needle.
Instead of just guessing, makes sense.
Exactly. We see a lot of facilities spending money on upgrades without knowing where the real losses are. Audits help prevent that.
And maintenance strategy is another topic that also comes up a lot when talking about long term cost. How does it tie into this?
Maintenance strategy is huge. Reactive maintenance, waiting for something to fail, is almost always the most expensive option. Predictive, or it's also called condition based maintenance, lets you address issues before they cause downtime or damage. It also helps avoid unnecessary service, which is another hidden cost people don't always think about.
Should operators examine their consumables as well?
Absolutely. Filters, lubricants, separators, they all impact pressure drop, energy use, and contamination risk. If air quality degrades, the system has to work harder to deliver the same performance. So something as simple as a neglected filter can increase operating cost without triggering an alarm.
And condensate management is another topic that doesn't get talked about a lot. Can you explain a little about that too?
Right, but it should. Improper condensate handling can add cost and environmental risk, especially in oil lubricated systems. And even in oil free systems, poor condensate management can cause downstream issues and compliance headaches. Again, it's not flashy, but it matters.
Another important piece of the puzzle is how compressors are controlled. How do system monitoring and IIoT play into long term cost control?
Yeah, this is a great topic, and visibility is everything. With modern monitoring tools, operators get real time insight into things like pressure, efficiency, loading, and vibration. That means instead of reacting after a problem shows up, you can spot abnormal behavior early and fix it. This reduces energy waste, prevents failures, and extends equipment life. It also supports sustainability goals by improving energy efficiency and reducing unnecessary consumption.
Thanks, Zach. We've talked about a lot today: pressure, controls, audits, monitoring. And for a lot of people, that's when it really clicks, when you see how all of those pieces connect in the real world. Before we wrap up, can you share with us an example where hidden costs were creeping in and what changed once the system got a closer look?
Yeah, and this is a great example of how hidden costs don't usually show up as one big failure. This situation came to me through one of our longtime service experts who was working closely with an automotive component manufacturer. When they walked me through it, it stood out immediately because everything looked fine on the surface, but the system was quietly creating disruption. They were experiencing repeated production interruptions. Nothing major enough to shut the plant down, but frequent enough to create inefficiencies and ongoing maintenance challenges. At the same time, their energy costs were climbing year over year, which raised the question if the compressed air system was really aligned with their operation.
So, what made this situation stand out the most?
Once the service team and channel partner took a closer look, an audit revealed a few common but costly issues. The first was that the compressors didn't have enough capacity to meet current production demand, so they were being pushed hard just to keep up. On top of that, the system was operating at pressure significantly higher than what the process actually required, which is a big hidden energy cost. Then, another issue discovered related to consumables. When the numbers were reviewed, annual consumable costs were coming in at over $50,000 a year, driven in large part by unnecessary filtration and the system working harder than it needed to.
So, how did they go about fixing everything that was going on?
The focus was on targeted data driven improvements. They upgraded to more efficient compressor technology that was properly sized for their specific demand. Next, they optimized system pressure so they were only producing the air they actually needed. And finally, they reduced unnecessary filtration. The result was about $100,000 in annual energy savings, along with lower maintenance costs, improved system reliability, and just as important, production disruptions dropped off.
And this is why it matters. This wasn't isolated, it's common. So, what's the big takeaway here?
The takeaway is that compressed air doesn't have to be a hidden cost. When systems are designed, monitored, and maintained strategically, operating costs come down, reliability improves, and equipment lasts longer. It's about treating compressed air as a system, not just a machine.
And that mindset shift makes all the difference.
Oh, yeah, it definitely does. And once organizations start looking beyond the price tag, better decisions follow.
Zach, thanks again for joining us today. Always appreciate your help and insight.
It's been a great conversation on some really important topics. Thanks, Barb.
And to our listeners, thanks for joining us on another episode of Beyond Compression, an FS-Elliott University podcast. If you'd like to dive deeper into the case we discussed today, the full write-up is linked in the show notes. Be sure to follow us on LinkedIn and Facebook for more episodes, product updates, and insights from our engineering and service teams.